Good afternoon, everybody. So, welcome to this webinar. Okay. So, today we are going to talk about graphical neural network. So, this is a new way to do the forecasting in different form of projects, except the time series. In time series, we know about the thing is that the traditional forecasting method is very good. There are the various forecasting model, XGBoost and other models are there which are very good in predicting the time series data. But what about the data which we have some kind of patterns or a pattern regarding to travel from different place to different place? The data which is going to travel from different location to different location, from different department to different department, from different places to different places. So how we are going, like, consider there is a one bird. Okay, there is a one bird which will going to travel around the globe. Okay, so what will be the forecasting pattern for that bird will be going to travel at that point or some specific point at what time. So through that, there will be some kind of pattern or a network we are going to build. Through that, we are going to do the forecasting. So for that, we are going come into the picture the graphical neural network. So this graphical neural network is a graph structure we are making of the data, and through that relationship, we are able to forecasting the different aspects of our data. So as we go, yeah. So what is the graphical neural network? So in the deep learning for the graphs, GNN is a specialized neural network designed to learn graph structure data, capture the more complex relationship between the entities. More complex relationship between entities means one, like in time series, there is a pattern. Time by per second, there is a structure or there is a pattern. But in a graphic, when we are having a complex structure or a complex design, there will be a connection with one neural network or one node with have a different multiple connections. So when we want to analyze those kind of connections, then we are going to need the graphical neural network. Okay, this graph structure. Okay, this graph structure have a networks of nodes, okay, which we are going to call it as the entities, and there is the edges, which we are going to call the edges. Okay, from the foundation of the GNN data representation, we are able to find out that those flow of an entities towards their relationship. To track all those things, we are going to need some kind of format or structure. Okay. So whatever the information they are sharing in those nodes and the relationship edges, there are whatever the things they are passing through a different node, all those things we are capturing through the graphical neural network. So this graphical neural network going to be help in excel in the complex modelings, okay, social network, molecules or sensor grids or interconnected systems. So, so there, I told you beginning also, there is a difference in traditional and GNN forecasting. So first in the data structure. So GNN, just a minute, just a minute. Ah. So in GNN forecasting, the graphical structure data, okay, the graphical structure like this is one node, and this node have one kind of edges, which we are going to call it line or we are going to call it as a relationship. Okay, but in the traditional forecasting, we have a time series data and this series in a sequence or in tables. Okay, like 1 hour data, 1 day data, okay, 1 day, 2 day. So these are in sequence. But in the graphical structure, there will be a no sequence. The one node can be connected with another node. This node can be connected with another node. This node can same node can be connected with the another node. These multiple connection will be having for the single node. So this kind of things we are going to analyze through the GNN forecasting or graphical neural network forecasting. Dependency of the modeling. Okay, direct and indirect relationship we are going to find in this GNN. But in for traditional forecasting or sequential forecasting, we have a independent variables or series. So, which where these models are suited best, the interconnected data like traffic, products, sensors. These are the interconnected nodes. So, in those things, they are going to be a best fitted model for the and this traditional forecasting is a single independent to the time series. Okay, so variable linked or influence each other. There are where the variables are influencing the other variables. At that point, we have to go with the GNN forecasting. Okay. And when we have to go to build traditional, when stationary or weekly correlated series are there, they are the correlation or influence between the one data point to data point, but there's some kind of correlation between those data points. At that time, we are going to have a traditional forecasting we are going to use. Okay. But the influence or correlation should be a stationary. Okay. It should not be dynamic or the some other thing. Okay, what are the tools we are going to use? PyTorch, Geometric Library, DGL, Spectral, Stellar Graph. Or I was said in traditional, we are going to use XGBoost, Arima, LSTM, Prophet, XGBoost, or those things we are going to use the models we are going to use in traditional forecasting. So, example like traffic flow, retail demand, okay, retail demand, disease spread, all those things we are going to use in graphical GNN. Stock price, we are going to forecast, weather forecasting, single product sales forecasting, all things we are going to use with the traditional forecasting. Okay. Then we are going to have the things like application. For the application purpose, traffic predictions in where we can use the GNN forecasting. Okay. Retail demand, inventory forecasting by the modeling the relationship between the products and the stores. Okay. Disease spread. Like in COVID, we have a disease spread of or network of the spread of diseases. There also we can have used the GNN, like predict the infection by the connecting with the regions through the mobility of the networks. Then we have what are the best practices and insights we can gather from GNN. So maximize GNN forecasting effectiveness through the strategic model design and implementation practices. Okay. Hybrid models, we can use GNN with the LSTM. Okay. Leverage strength with both approaches. Improved accuracy and for the complex data set. If we have a very complex data set, it will going to improve our accuracy in finding the relationship. Okay. And graph design, define the informative nodes and edges carefully. Okay. Connect by the similarity of the real relationship and critical model performance. Okay. Then second is performance monitoring. Track complexities and computational requirements. Trade-offs. What are the trade-offs we are going to look for? The balance and accuracy, what we are gaining with the resources and the cost we are using in the doing the training the network or forecasting models. Okay, implementation, the plan, real world deployment, and have already always all the models have their own challenges and all models have their own best part or best side also, advantages and disadvantages. Okay. So these are the some real example for the GNN forecasting, like product demand forecasting, retailing product by the similarity by the co-purchasers pattern. GNN combines with the deep AR outperform the traditional model, especially for the new products. Okay. If we want to introduce the new product, those new products don't have any kind of data or the patterns in the market. So how we are going to predict those kind of product sales or forecasting sales? So through the GNN, we can also able to achieve that with the limited history, improving the stock planning and reducing the loss sales. And in COVID-19, regions models are as noted with their edges reflecting the travel patterns of the peoples, and GNN predict those infection surges or days in advance, outperforming the model to ignore the mobility of the data. The traditional modeling, which we are going to ignore the mobility of the data of the regional interconnection, and through that we are not able to detect the spread of the diseases. But through the GNN, we can able to do that. Okay, performance and details. Both example demonstrate these example like GNN and traditional method. Okay. Significant accuracy improve overall traditional forecasting method, validating the power of the graph-based approaches and interconnected system. Through that, we are able to know the accuracy and most accurate accuracy or higher percentage of effectiveness we are getting through the GNN forecasting. So this is all the things we just summarize all the things we are going to look have in GNN. Okay. So yeah, for thank you for if there's any question you are welcome to ask, or otherwise we can wind up this webinar session. Okay. And we will meet next time at same time. Okay. Thank you.